All right, now, after all the mark and recapture, after all the random sampling stuff, we use those to get numbers on how many species might be in a given area. And the reason we collect those numbers is because we're going to extrapolate for a larger area and then try to see how healthy, how even, how rich the area is in terms of biodiversity. So a couple things we're going to need are going to be species richness and species evenness and something called the Shannon index. So I'm going to be hopping back and forth between these couple of things here. These are the equations that we're going to need. Species richness is really easy. It's just the number of different species represented. So if I were going to do these in order, it would go like this. Species richness first, calculate Shannon index second, and then this H prime comes from Shannon index. This S comes from species richness, so that's the natural log, and that gives me E, the species evenness. So I want to focus on this video on these two things and then a little bit on Shannon index. We'll do most of our work on Shannon index tomorrow. Species richness is really easy. The only issue with these three numbers is there's no unit. They're just straight numbers. This measures biodiversity. How many different species are in the area? Higher the number, the higher the species richness. Again, pretty simple. But all you can do with any of these numbers is compare one area to another. It like a 2 or a 4 or a 7, it doesn't really mean anything unless you compare it to another area. So if I said the species richness is 2, it just means there's 2 different species in the area. If I say the species richness is 4, there's just 4 different species in the area. Now, species evenness is asking us how are those species distributed, whether it's 2 or 4 or 5 or 7. Basically, does one species dominate the area, or are they evenly distributed? So some pictures here to help us out. All right, so the first one. This one has high richness. So again, I'm going to go back to species richness. Just how many things are there? Well, there's 1, 2, 3, 4, 5, 6 different things here. All right, how are they evenly spread out? Are they clumped together? Well, you know, I look over here, I got a blob and a square and a pentagon and a triangle. Like, it's not dominated by any one thing. Like, if I look at a little area, it's not clumped together in like one particular thing. So we say that's high evenness because they're evenly spread out. All right, what about this one here, down at the bottom? This is low richness. Why? Because there's only 2 things. Again, species richness, how many kinds? Well, there's only 2 versus 6. What about evenness? Like, okay, there's 2 species, but are they evenly spread out? No, it's totally dominated by the triangle. Okay, there is not an even amount, okay, of squares in this area. So comparing, look, I'm going to go to triangles and squares versus pentagons and stars. What's the richness like? Very low richness. There's only 2 species. But what about evenness? Well, if I look at in a particular area, so any one particular area, well, like right here, if I cut that little square, well, there's some pentagons and stars, and, you know, cut this area, well, there's some pentagons and stars, and there's, you know, it's pretty even. You know, they're spread out pretty evenly. What about the bottom one right here? Okay, high richness. Okay, 1, 2, 3, 4, 5, 6 things in the area, high richness. But what about the evenness? Well, if I look at a corner here, I mean, it's totally dominated by the circle. Okay, let me go over here to this little quadrant. Well, it's still totally dominated by the circle. What about over here? It's mainly circles. So while the area has high richness, very low evenness because it's dominated by the circle. So that explains species richness, again, just counting, versus species evenness. So I showed you the concept of species evenness, but you have to be able to calculate and give it a number. In order to give it the number, you need the natural log of the species. Okay, that's easy. So, like if I'm going back to my examples, 6, so the natural log of 6 versus the natural log of 2. But this H prime is kind of hard to get. So what we use is we use something called the Shannon-Wiener index. People laugh at the name, okay, like middle schoolers, so we only call it the Shannon index for the most part. But the only thing I need you to know for right now, like I said, I'm going to go into detail. I know these equations look, a little daunting sometimes. They're actually pretty straightforward. All it's really asking is for percentages, okay? And you're going to add up different percentages here. I just want to clarify a couple things that we're going to need. So I'm going to use this equation here at the bottom and a little bit of here at the top. Which one you end up using doesn't really matter to me. Okay. So what does n, like small n and little n mean in this equation? So n just means the total. I'm going to put nx or n sub 1. You could be n2, n3. Basically, it's a number of species of x. So if I'm looking over here, so my valley oak, that will be my first species. Okay, leather oak is 2, blah, 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 blah. Basically, when I'm taking this number and dividing it by the total, I'm getting a percent. That's what p sub I over here means. So all I'm asking for is a percent. Eventually, I'm going to get the negative sum, so that's what that symbol is, the negative sum of all of this. So I'm going to show you how I get it for one line. So first off, I need the total. So 6 plus 5 plus 7 plus 10 plus 12. You might need to do the math on a calculator. You shouldn't, but that should give you 40. Now, it's just a percent. Again, I'm taking n of x, or n1, so that's 6, and dividing it by n, my total 40, to get my percentage. So it's just 6 divided by 40. And that's going to give me 0.15. Now for the next part, so for this, you're going to have to get the natural log of the percent. And again, I'll walk you through the rest of this in class, but I just wanted to clarify this part first.